I am. I'm blaming everyone. It's just I'm looking at you because you actually are making eye contact. Everyone else is like, I'm not going to make eye contact.
I'll make eye contact.
All right. I know. I appreciate that because you know what? That shows how big of a person you are. All right. Moving on. So we got to move on. So complex numbers are all, I have to say for the video, don't talk, do not talk. Complex numbers are any number is a complex number. And imaginary is, it has an I. So it's that simple. If you see an I, you'd say it's imaginary. Moving on, real, everybody, now put a red box. It's not red, but my red box. Put a box inside complex number. These are for everything that's not imaginary. We then need to make our way through this list. You then say, if it's not imaginary, it must be real. Real numbers just don't have an I. See, I wrote that. Real, you can just write the word real, or you can use this fancy R. I just write the word real. Real numbers have no I. So these are all examples I've written of real numbers. 7/5, 2, root 7, 3 plus root 2. It's really easy to determine a real number. It just doesn't have an I. Do you all understand? Yes? Okay. Now, so I guess now we could talk about rational versus irrational. So everybody, rational is in pink. Rational means it can be written as a fraction. But I also wanted to add in there, it's also ending decimals. If you can see the end of the decimal and it has a pattern, so if you can see the end of a decimal and it has a pattern, you're going to say, yes, it's considered rational. For example, if you were to take your calculator and do 1/3, isn't 1/3 a fraction? But you could also see it written as if you were to type that into your calculator, you could also see that 1/3, they might write the answer as 0.333, and it just is repeating. So this would still be, even though it's a decimal that goes on, it has a pattern. It's a repeating decimal. That's considered a rational number. So I like to say rational numbers can be written as a whole number or a fraction. You guys, a whole number is a fraction. For example, isn't 7 the same thing as 7 divided by 1? So that's considered a rational number. It's written as a whole number or fraction. So these are examples of rational numbers. 3/5 is a fraction. 0.5 is an ending decimal. Yeah? 0.5 is an ending decimal. You can see the end. 0.333 repeating, it has a pattern. Even though it goes on and on, it has a exact pattern. So this would be considered a rational number. So then go over to gray. So what qualifies something as an irrational number? It's the exact opposite of that. It can't be written as a fraction. So I like to say a never-ending decimal with no pattern. Notice I did a little bulletin point. Irrational numbers are numbers that cannot be written as a fraction. We see these manifested as, if they can't be written as a fraction, they have to be written as a decimal. It's a never-ending decimal with no pattern. Or a radical that doesn't simplify. Root 2 is a decimal that cannot be written as a fraction. Let me say that again. If there's a radical that does not simplify, then it is an irrational number. Radicals are irrational. They're a pretty way of writing a decimal. Did you hear that? A radical is just a decimal value. It's a square root of a number, for example, in this case. If it simplifies, then we will look at and see if there's still a radical left. If there's ever a radical that cannot simplify, it's considered irrational. So with just even these in mind, let's go do a few examples to make sure our brain is getting what we've learned so far, just so far. So let's go look at -10. -10 is complex, yes? Yeah. Is it imaginary or real?
It's real.
It's real. Okay. Now, is it rational or irrational?
Rational.
It is a fraction, right? -10 is the same thing as -10/1. So it'd be considered rational. And that's all we've learned up to here. Is that making sense? Yes. Okay. Now, all right, let's keep moving on then. We'll come back and do all these examples. So if it's rational, then it can be also considered an integer. So notice the green thing. Integer is a whole number. It can be positive or negative. So within rational, if it's rational, it's a whole number or fraction. If you see that it is a rational, you would check. Is it a positive or negative whole number? If so, it's called an integer. I'm also memorizing these with you. Once you get a little higher, they don't care. They're just like this, like we're just doing math. Today, in secondary 2, they want you to use correct language in the future. So what is an integer? A whole number that is positive or negative. You wrote that down. So I gave some examples. 2, -2, 10. Those are all integers. Then integers can be considered whole numbers. Interestingly enough, whole numbers are only the numbers 0 and above. However, they have to be whole numbers. When I say whole numbers, I think of like non-fractions.
Yeah, it's like 1, 2.
Yeah, so it kind of, a whole is a whole, like, yeah, exactly. So non-decimal answers, non-fractions. So whole numbers, for it to be a whole number, it can be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You get the picture, yeah?
All the way to 10 billion.
Okay, sweet. Yeah, we'll stop at 10 billion, sure. And then a natural number is a whole number that's above 1. A natural number is a whole number that's above 1. Well, 1 and above. 1's also counted as a natural number. So basically, it's just throwing out 0. Do you guys see what I'm saying? Because didn't we just say whole numbers are 0 and above? Natural numbers are 1 and above.
So it just counts out 0.
It just cancels out. Yeah, it just 0 doesn't count.
But it still can't be like a fraction or decimal.
Correct. Still no fractions or decimal. These have to be integers, which integers are whole numbers.
But it can be a negative number, right?
Nope. So it depends on what you're saying. Integers can be positive or negative. But once we get to whole numbers, it's 0 and above. Wouldn't that only be positives? And then natural would be 1 and above. So those would only be positives. So it just takes memorization. I am also right now having to memorize this with you. I've only taught upper division math for a long time. And so like a lot of these, I'm like, oh, I didn't remember that till today. So we're memorizing it together. All right. So you basically just go through the process. Like I'm going to just erase and start over here, if you don't mind. All right. So I look at, for example, -10, and I say this is a complex number. It's also real. It's also rational. Then I move on, and then I say, is it an integer? Yes.
But it is not.
But it just takes memorization. Like I said, integer is whole numbers, positive and negative. So I'm also like closing my eyes, picturing it in my head so I can remember that. But it is not whole or natural because they can't be negatives, right? 0 and above, 1 and above. Okay. All right. I also recommend always simplifying your radical before you name it. So now, if we look at this one, the square root of 25 is 5. So we'd go through our process. It is complex. We always say yes. It is real. It is rational. Is this true?
Yes.
It's also an integer.
Yeah.
And a whole number.
And a natural.
And a natural number.
So it just classifies as natural, right?
So I see you're saying if you said natural, then it would encompass everything up. Is that what you're saying? Yeah, that's true. But they want you to list them out individually.
Really?
He's making a good point. I think so. Maybe not. We'll look at, I would accept either answer. Do you guys see what he's saying? He's thinking advancedly. He's saying if it counts as a natural number, well, actually though, if we work backwards, then how would we say that we know it's not irrational? Do you see what I'm saying? I think we just list them all out. All right, 2 root 5. Does the radical simplify? Root 5, does that simplify? No, so leave it. Let's go through the process. It's complex. Yes or no?
Yes.
It is real, but it is, irrational. And then we're done, right? After you say irrational, you're done. Is there anything inside the irrational box?
No.
It's not going to be integer, whole number, or natural number. Okay, let's go to 4i. We would say it is a complex number and it's imaginary. And we're done. Once you say imaginary, you stop.
So imaginary numbers are not rational.
Exactly. All right, so look at -6 plus I. You would say it's complex. And it's imaginary, so we're done. All right, root 27. We first need to check, does this radical simplify?
Yes.
It does. We know that that's 9 times, which is 3 times 3 times 3. We're pulling out groups of how large? 2. So we pull out and then root 3 is left underneath. But do you see that radical did simplify, but there's still a radical? Okay, so it's irrational then, right? We know it's complex. It's real, it doesn't have an I, but it's irrational. There's a radical still that didn't simplify. I'm telling you, if it still has a radical that doesn't simplify, that's considered irrational. Does that make sense? Just takes memorization. So looking at 3 plus root 3, it's complex, it's real because it doesn't have an I, and it's, oh, there's no I.
It's just irrational.
Irrational. There's a radical that doesn't simplify. Yes, isn't that true? All right.
Easy.
So I have to scroll down to my next examples. I'm going to be away from my little chart, so you need your chart to help me out. So like I said, simplify before you decide your answer. If you see root 2 times root 8, I need you to remember this. This was new, I guess new to us this year. When multiplying radicals, you can multiply what's underneath the radical together. So you'd say they're both square roots. Because they're both square roots, I can put them under the same root. Which means this is the square root of 16. Does the square root of 16 simplify?
Yes.
It is? Okay, it's 4. So now we would say it's complex. It's real. It's rational.
It's natural.
It's also natural. I'm getting there. Yep.
Integer.
Integer,
It's whole and it's natural.
whole, and natural. This meets all the requirements.
You could technically just say complex and natural.
It's not natural.
Okay. We're going to list it out because that's what they want us to do, but I get what you're saying. Negative 5 plus 8 is?
Complex.
It's 3 though, correct? Okay. So you simplify first. So you'd say complex, real, rational, integer, whole number, and natural.
He is not on trend.
All right, what about 2 plus pi? Now, pi is a decimal. They didn't want to write, everybody, if you were to type pi into your calculator just to see the value,
9 is an irrational number.
it's actually, when you do it in your calculator, it appears like it stops. You're saying you had to memorize it in a different class for fun?
I memorized it.
Yeah, so
At 1.32.
it doesn't matter if you memorized it, but my point is,
Oh, it's irrational.
yes, but let me just say this. You're not talking, you're listening. Pi is a never-ending decimal. You have to have knowledge on pi to know that. It's a never-ending decimal.
Without a pattern.
Without a pattern, exactly. So we would know that this is considered
Irrational.
complex, because everything's complex. It's real, because there's no I, but it's irrational.
How does anyone end up with pi? I don't understand.
Pi is just a number that's seen in real-world phenomena. So they kept seeing this number show up, 3.1424, whatever it was, in the real-world situations over and over again, and they're like, this decimal shows up so many times, let's give it a special name. Let's give it a special value. Do you see what I'm saying?
Show up then.
We could look it up on the internet. I don't know right away.
Hopefully that answer would be 5.
No?
5.1415.
Okay, yeah, but it's a never-ending decimal. Yeah. Okay, right here, I need you guys listening because this will trick a lot of you if you don't remember your math.
I remember 3-2.
Okay, don't talk. 3 root 2 plus 1 root 2. You have to check. Adding radicals and subtracting radicals is picky. You're not allowed to just float everything around like with multiplication. You can't just put it under the same radical. That's not how addition works. Addition has to be the same radical. Let's check. Oops, sorry, I erased that on accident. Everybody check. Is the radical the same? That's not it. We also have to check, is underneath the same? And if it is, we add apples to apples, oranges to oranges. So we have 3 apples plus 1 apple, which is 4 apples. The apple doesn't change. Do you guys understand?
Full square roots of 2.
So now answer the question. It's complex. It's real. But it's
Irrational.
irrational. What are your questions on adding radicals? So what's 3 root 3 plus 7 root 3?
10 roots of 3.
10 roots of 3.
10 roots, no, 10 roots of under the
Okay, right here, with this one, you'd say multiplication is not picky. We can go like this. 3 times the root of 4, which equals 3 times
It's 6.
2, which is 6.
It's not even.
So now you would say the answer is complex, real, rational, integer, whole, and natural. Do you guys get the picture with this? Do you need more examples? Okay, you're gonna go work on the homework. Yes.
When you multiply radicals together, do they have to have the same?
They actually don't. But we'd have to learn how to do it because you do have to do it a little differently. Because right now, all we're seeing is we put them under the same root, right? But if they're different roots, you have to do an extra step. And I could show you that sometime if you're interested.